Hi, good evening to everyone. Welcome to GATE Academy. I hope all of you are fine, all of you are in good health and आपका preparation बहुत अच्छा हो रहा है. I think your preparation is going excellent. Is my voice is audible? We'll start the session. Is my voice is audible? Yes. Yeah, welcome to all. I think you have followed my all previous sessions. We have taken excellent sessions on moving iron instrument, PMMC instrument, dynamometer instrument, electrostatic voltmeter. We have taken measurement of voltage, current, power. Sauvik Singh, I will take one separate session, don't worry. I will take a separate session, don't worry about the three-phase power measurement also. I will take a session. I will take a session, Sauvik, Sonak Mukherjee, everything clear? Chalo, jaldi se jaldi start karenge. Yesterday what we have discussed, how many of you attended the yesterday's class? In yesterday we have discussed the CRO, right? Cathode ray oscilloscope. So in cathode ray oscilloscope we have discussed the measurement of frequency and we have discussed measurement of phase, measurement of frequency and measurement of the phase. Okay, चलो जल्दी से जल्दी हम start करेंगे, क्वेश्चन start करेंगे बेटा, क्वेश्चन start करेंगे. चलो, so try to answer this question. Try to answer this question. फटाफट try to answer this question जल्दी, because आज हम error analysis भी start करना है. So after the completion of this problem we will go. The simultaneous application of signal x of t and y of t to the horizontal and vertical plates. So x of t is for horizontal, y of t is for vertical, y of t is for vertical plates. Produces a vertical figure of 8 display. Produces a vertical figure of 8 display. So this is the Lissajous pattern. So this is a Lissajous pattern. Vertical of 8 display. Vertical figure of 8 display. Okay na? Vertical figure of 8 display is going to start like this. So now this is a Lissajous pattern. So if you see the Lissajous pattern, number of horizontal tangencies and number of vertical tangencies, if you observe, number of horizontal tangencies are 1, number of vertical tangencies are 2. Okay na? Yeah. Now what is the question asked? If P and Q are constant and x of t is P sine of 4t plus 30, then y of t is equal to dash. Then y of t is equal to dash. Dear student, try to answer this question. Which books instrumentation student must be read? A.K. Sahani, वो बता बड़ा कहानी है. A.K. Sahani textbook. A.K. Sahani textbook. Okay na? You can read the A.K. Sahani textbook. Yeah. Thank you sir for all your efforts. Yeah, Sauvik Singh, thanks for your comment. You please see me some symbols here because you please express your gratitude. Please express your gratitude. Thanks to GATE Academy, some symbols, some thanksgiving symbols, and share this message like everything. Share this message like anything to all the WhatsApp group, Telegram group, so that in this pandemic situation, ye 3 months mein, we have to get some good experience of subject. Okay, option B bol raha hai. Very good. Kaisa, let us see here. So we know that frequency of y, I think all of you know the basic expression. Yesterday we have discussed frequency of the signal applied to the vertical plates, frequency of the signal applied to the horizontal plates is given by number of horizontal tangencies, number of horizontal tangencies by number of vertical tangencies. number of vertical tangencies. Okay na? So that is a formula na. So what is that? Now Fy by Fx will be, sorry, Fy by Fx will be how much? Jaldi fast tell me. Fy by Fx, fast बहुत सारा questions करना है. Number of horizontal tangents is 1, number of vertical tangents is 2. So definitely Fy will be Fx by 2 na, Fx by 2. So frequency applied to the vertical plates will be half of the horizontal plates. Okay, so it goes, okay, no problem. Okay. See, in this particular pandemic situation, you may not read the textbooks. Textbooks are okay for our understanding, but for you examination point of view, you need more practice. For practice के लिए you have to start test series. More number of questions you have to practice. Get the concept from the classes and try to attempt more test series. Okay, that will be useful. So what is the answer now? फटाफट बोल दिए. So P sin 40 plus T. So this is omega T. Omega T na. So what is the answer? So omega T plus 5. So this is our half of that signal should be na. Yes or not? So what is the answer? जल्दी बोलिए. I'm waiting for your answer. Okay, so frequency of the X is how much? Frequency of the X is how much yaar? Frequency of the X is how much? Sin omega T, that is 4T. Omega is 4T, sin omega T. Omega T is 4T. That means omega is equal to 4. So half of that will be 2 na. Omega is equal to 2 pi f. 2 pi f is equal to 4. So f is equal to 4 by 2 pi. इसमें half होना, that means 2 by 2 pi. So that is possible if I am taking this particular signal na. So what is the correct answer? Option B is going to be the correct answer na. Option B is going to be the. Sir, what will happen if there is no vertical tangent? Vertical tangent, without vertical tangent signal cannot be there, beta. Vertical tangents will be given. Lissajous patterns will be formed. For that pattern, if you draw a horizontal line, vertical tangent, then definitely there is a vertical collision. Without vertical, there is no possibility of finding. Definitely there is a horizontal, definitely there is a vertical. Okay na? Chalo. Next question. Try to answer this question. Question number 86. In your booklets, the questions are there, dear students. I have forwarded already booklets. I have already forwarded the booklets. So try to answer question number 86. In your booklets, question number 86, I already forwarded you the booklets. The probes of a non-isolated 2-channel oscilloscope are clipped to points A, B and C in the circuit. So this is point A. I think all of you are able to see this picture clearly. So this is point A, this is point B, this is point C. The probes of a non-isolated 2-channel oscilloscope are clipped to points A, B, C in the circuit of the adjacent figure. V in is a square wave. V in is a square wave of a suitable low frequency. The display on channel 1 and channel 2 are as shown on the figure right side. So this is a channel 1 waveform and channel 2 waveform. Then the signal and the ground probes are S1G1 and S2G2 of channel 1 and channel 2 respectively are connected to the points AB, CA, AB, CB, CB, AB, BA, BC. What is the answer? Try to answer this question, dear students. Hi Bhanusri Chauhan, after a long gap. Hi, how are you? Okay. So the probes of a non-isolated two-channel oscilloscope are clipped to points A, B, C. They are clipped to points A, B and C in the circuit of the adjacent figure. V in is a square wave of a suitable low frequency. So this is the V in. So this is the V in. Okay, this is the V in you can take. This is a V in signal. Okay. V in is a square wave of a suitable low frequency. The display on channel 1 and channel 2 are shown by the waveforms. Then the signal and ground probes S1, G1 and S2, G2. So if you want to see the channel 1 waveform means the CRO will be having two probes now. So CRO two probes will be there like this. So this is our S1, this is our G1. Similarly, this is S2, this is our G2. Okay, so this is channel 1 probe and this is channel 2 probe. This is channel 1 probe and this is channel 2 probe. Okay, the display on CH1 and CH2 are shown on the figure, on the right side figure. Then the signal and the ground probes S1, G1 and S2, G2 of CH1 and channel 2 respectively are connected to the points. How to understand this question? Good evening, Richita. Answer C, sir. Are you sure? No. If you see here, this is the common terminal. B is the common terminal. B is the common terminal. So, you want to see the signal across at the R, that means at A and B. So, A is connected to S1, B is grounded. Next, C is connected to S2, B is grounded. Then I can see the voltage waveform at the R and voltage waveform at the inductor. So, S1 should be connected to what? S1 should be connected to A and B is the common terminal. B is a common terminal. So, G1 should be connected to B. Next, S2, G2. S2 should be connected to A. S2 should be connected to C. S2 should be connected to C and G2 should be connected to whom? B. Dear student, this is a sequence AB, CB. So, option B is the correct answer. Option B is the correct answer. Why? Because this B is a common terminal. I want to see this B as a common terminal. Why? Because this A to B, A is the signal, B is the common, C is the signal, B is the common. Otherwise, you cannot get the channel 2. So, what should be connected to channel 2? Channel 2 should be connected such a way one of the terminals should be common. So, B terminal is common, dear students. B is a common terminal. All of you understood? B is the common ground terminal. Clear or not? So, the correct answer is ABCB. Yes or not? So, this is our fast, jaldi se jaldi response diye. So, this is S1, this is ground 1. So, ground should be common na? Ground should be common. So, this is S2, this is Z2. Okay? Please show me the thumbs if you understand. Shall we go for the next problem? Shall we go for the next question? Please show me the thumbs. Chalo. Next question. Try to answer this one. Yeah. This question. Question number 84 in your booklets. Please, you have already the booklets. Please follow the booklets. Don't waste the time. Question number 84. Question number 84. See, this is the waveform, dear student. Just let me write. I think it may not be visible. So, this is the waveform. Is it visible for all? I will use separate ink. So this is one waveform and this is another waveform. So try to understand this question. This was a gate questions. We are not discussing altu faltu questions. We are discussing the conceptual questions of the gate exam. The time per division and voltage per division, time per division and voltage per division, axis of an oscilloscope have been erased. Is it visible? The question is visible for all of you? Yeah. So they have erased the times per division and they have erased, the units are erased. A student, just like our किसका नाम लेंगे, हमारा रुचिता का नाम लेंगे. A student like Ruchita connects 1 kilohertz 5 volts peak to peak square wave, 1 kilohertz 5 volts peak to peak. Okay na? So what is the frequency of this? Frequency is equal to 1 kilohertz. And what is the amplitude? Amplitude is 5 volts peak to peak. 5 volts peak to peak. Square wave calibration pulse to channel 1. So this is channel 1. This is channel 1 of the scope and observes the screen to be as shown in the upper trace of the figure. So this is the upper trace of the figure. An unknown signal is connected. So this is our unknown signal to the channel 2. Channel 2 का unknown signal है. Channel 2 को क्या connect किया? Unknown signal is connected to the lower trace of the scope. If the time per division and voltage per division on both the channels are the same, then the amplitude P to peak and period of the unknown signal are respectively dash. So he is asking what is the amplitude and what is the time period of this unknown signal. Can you do it? Do you understand the question, Ruchita? So first Ruchita has taken one particular waveform which is having some known frequency and known amplitude. Known frequency and known amplitude. So for that, a unknown signal is connected on the channel 2, both they are compared. So if the time per division and volt per division on both channels are the same, so how to do this problem? फटाफट जल्दी बोलिए, time per division and volt per division चाहिए मुझे. So on x-axis will be having time per division. On y-axis will be having volt per division. So if the time per division and volt per division of above and below are same, then what is the correct answer? फटाफट जल्दी बोलिए, जल्दी. I am waiting for your answer. Telegram link is already posted in the previous YouTube classes and it is also there in the present class link also it is there. Our team will post immediately Telegram link. Please post the Telegram link over there. It will be posted. You just be regular to the class. Yeah, how to answer this question? I am expecting the answer from you. I am expecting the answer from you. Anyone from the, yes. Sir, please explain about the sampling theorem. Why the sampling here, Vamshi? This question is nowhere related to sampling theorem, Vamshi. Vamshi, sampling theorem is not at all related to my subject of measurements. Okay. Anyway, sampling theorem में क्या होता है? The frequency of the sampling must be greater than 2 times of your measurement signal. That is the basic theory. जो कुछ sample करना चाहता है, वो sampling frequency must be more than 2 times of the measurement signal. Option A बोल रहे हैं, option D बोल रहे हैं. रुचिता is saying DA. DA क्या है? अच्छा, Nivesh is saying T. See, first of all, let me talk about this particular waveform. Let us talk about volt per division. If you see the frequency, so what is the frequency? So this is one cycle, am I right? So this is particularly one cycle. So if you see the one cycle, how many divisions now? 1, 2, 3 divisions. Okay. So what is the frequency? Frequency is equal to 1 kilohertz. So first let me calculate sensitivity along the x-axis. Sensitivity along the x-axis is what? Sensitivity along the x-axis is what? Time per division. Time per division. Okay na? Time per division. So if you see this signal, this frequency is 1 kilohertz. Frequency is 1 kilohertz means time is equal to how much? 1 millisecond. Time is equal to how much? 1 milliseconds. To cover 1 milliseconds, how many divisions are taken? 1, 2, 3, 4. Yes or not? So 4 divisions contribute 4 divisions contribute 1 millisecond. 4 divisions contribute 1 millisecond. Am I right or not? Yes or not? So 1 division gives me what? 1 division gives me what here? 1 division gives me how much? 1 by 4 milliseconds na? 1 by 4 milliseconds. Okay. So what is the time per division? 0.25 milliseconds na? So 0.25 milliseconds per division. So that is the sensitivity along x-axis. Am I right? Yes or no, dear student? 0.25 milliseconds per division, that is a sensitivity along the x-axis. 1 division 0.25 milliseconds, 2 divisions 0.5 milliseconds, 4 divisions. Am I right or not? Yes, 4 divisions will become 1 millisecond. So this is sensitivity along the x-axis. What about sensitivity along the y-axis? Fatafat, sensitivity along the y-axis. Sensitivity along the y-axis is nothing but volts per division na? That will be volts per division. If you see the peak to peak voltage, what is the peak to peak voltage, dear students? V peak to peak kitna hai? V peak to peak kitna hai? 5 volts. So this how many divisions? 1, 2. Yes or not? 1, 2 will cover 1, 2 will cover 5. Okay. So peak to peak is equal to 5 volts. Peak to peak will cover 5 volts. Peak to peak will cover 5 volts. So 2 divisions are contributing 5 volts. Am I right? 2 divisions only na? Fast here, how many divisions this is? 2 divisions. 2 divisions are contributing 5 volts. That means 1 division is equal to how much? 1 division is equal to 5 volts, 5 by 2 volts per division. That means what? So since that will be what? 2.5 volts per division. 2.5 volts per division. So that is a sensitivity along y-axis. Is it clear now? Now let us take this particular signal. So on the x-axis, how many divisions it is taking? If you take one cycle, if you take one complete cycle, so this is how many divisions now? So this is a one complete cycle na. So this is a one complete cycle. So 1, 2, 3, 4, 5, 6, 7, 8 beta. So 1, 2, 3, 4, 5, 6, 7, 8. This particular time per division, this particular volt per division is same to this unknown signal also. So what is the answer now? So along the x-axis, if you take one division is taking 0.25 milliseconds. So there are how many divisions beta? Fatafat. 8 divisions are there. So 8 divisions will take how much? Fast. What happened? Other people not responding. Other people not responding. 8 divisions kitna hoga? 2 milliseconds na? Yes or not? It will be 2 milliseconds or not? 0.25 into 8, 25 by 100 into 8, 5 5 ja, 5 20 ja. Yes. Am I right or not? 2 milliseconds or not? Yes, 2 milliseconds. Correct. So this is the next. Similarly, if you see the along the vertical, if you see along vertical, how much? How many vertically? How many divisions are there vertically? So how many vertical divisions are there? So this is the vertical divisions. If you see this particular vertical divisions here, so with respect to this 1, 2, 3. So 3 divisions. 3 divisions vertically. So vertically 1 division is equal to how many volts? 2.5 volts. So 3 divisions contribute how many volts? 7.5 volts. So answer will be 2 milliseconds and 7.5 volts. So 2 milliseconds and 7.5 volts. So option C is the correct answer. Option C is the correct answer. Nobody has given the correct answer. Ruchita, you are wrong. Nirvesh, you are also wrong. Yes or not? Nirvesh and Ruchita, you both are wrong. The correct answer is 7.5 volts and 2 milliseconds. All of you followed or not? Don't be in a hurry and don't be in a hurry and don't make mistakes, dear students. Don't make mistakes, okay? Don't make mistakes. Don't make mistakes, dear students. Don't make mistakes. Once again, I am giving you the diagram. आपके बारे में explain कर रहा हूँ. Don't make mistakes. Okay? चलो. Clear all of you? Anybody any doubts here? Mistake किया ना रुचिता आप? हाँ. So 2 milliseconds आएगा. See, from the given information, this is 1 kilohertz means 1 milliseconds. ये पूरा time 1 milliseconds है. So 4 divisions are contributing 1 millisecond बोलो तो 1 division will be 0.25 milliseconds. So इधर 8 divisions है, पूरा एक cycle पूरा लेना है. This is एक cycle पूरा लेना है, एक cycle के लिए 8 divisions है. 1 division is equal to 0.25 milliseconds. So this is 0.25 milliseconds. This is 0.25 and this is what? 5 volts peak to peak means this is 2.5 volts. Okay na? So horizontally how many? 1, 2, 3, 4, 5, 6, 7, 8. 8 into 0.25 2 milliseconds आएगा. Vertically कितना? 2.5, 2.5, 2.5, 2.5 into 3, 7.5 volts आएगा. Option C मजा आएगा. Option C correct है ना? सब लोगों को समझ में आ गया? I think all of you understood. If you understood, please show me the thumbs here fast. Fast, make it fast. This is a beautiful questions. Previous gate questions. Ruchita, are you clear? Dear students, previous students, those who have given the wrong answer, are you clear? Option C is going to be the correct answer. Remaining students, Ruchita and Dirvesh, everybody, very good, very good. Chalo. Let us go for the next problem. Yeah, try to answer this question. Fadafat. Fadafat. I'm expecting the answer from you. Fast. A voltage of 6 cos omega t, V is fed as a Y input to CRO. The waveform seen on the screen of the CRO as shown in the figure. The Y and X axis settings for the CRO are dash. So if you draw the line like this, now tell me, fast, I am expecting the answer. The waveform seen in the picture, answer please. What is the voltage signal beta? What is the voltage signal? Voltage is given as how much? 6 cos 100 pi t. So if you write this as a voltage of 6 cos 100 pi t V is fed as a Y input to CRO. The waveform seen on the screen of the CRO is shown in the figure. The Y and X axis settings for the CRO are respectively dash. See, this is omega. Okay, so this is omega. Omega is equal to 100 pi. That means 2 pi f is equal to 100 pi. That means f is equal to 50 hertz. Then what is the time period? Time period will be 1 by 50. 1 by 50 seconds. That will be how much? 2 milliseconds. 2 milliseconds. Correct? Time period will be 2 milliseconds. Am I right? Yeah. What is the answer now? $20 milliseconds, na? 20 milliseconds. 20 milliseconds. Correct? 20 milliseconds is the time period. Next, peak amplitude is how much? Amplitude is 6 volts. 6 volts. So first let us see how many are there. Whether you if you take like this, actually cos signal na. So if you take like this, so 1, 2, 3. 1, 2, 3. So these are the 3. So 3 signals. 3 blocks. So 3 blocks should cover 6 volts. That means each block will cover 2 volts. Each block will cover 2 volts. Yes or not? Each block will cover 2 volts. Then how many number of horizontal divisions here? 1, 2, 3, 4, 5, 6, 7, 8. Okay. So कितना होगा? Option D होगा. I will remove this, otherwise you will confuse. Okay, I will remove this so that it will be clear now. Check. So time is equal to 2 milliseconds. So that is the frequency. So what is the time? 2 milliseconds is the time period. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 divisions. 10 divisions should cover 2 milliseconds. Sorry, 20 milliseconds. 20 milliseconds. Okay, now am I right? This is 20 milliseconds. Make a small mistake. 1 by 50 means 20 milliseconds. Na? 1 by 50 means 20 milliseconds. I think not. Yeah, 1 by 50 is 20 milliseconds. 10 division should contribute 20 milliseconds. That means 1 division must be how much? 1 division must be 2 milliseconds. So 2 milliseconds per division. Next, peak voltage is what? Peak voltage is what? 6 volts. So 6 volts means it is 2 volts per division. So option D is a correct answer, na? Yes or not? 3 divisions must contribute 6 volts. So 1 division must be 2 volts, na? 1 division must be 2 volts, na? So vertical is how much? This is how much? 2 volts per division. On x-axis is how much? On x-axis how much? 2 milliseconds per division. Am I right now? Dear student, check it, check it, check it. 2 milliseconds per division. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 divisions, 20 milliseconds. 20 milliseconds time period is matching. Next, if you see the peak amplitude is 1, 2, 3. 3 each must be how much? So that 6 volts. Peak amplitude is 6 volts, na? This is 6 volts peak amplitude. Okay, this is 6 volts. So this is 2 volts per division. So 2 volts per division is a vertical sensitivity. 2 milliseconds per division is horizontal sensitivity. All of you understood, dear students? D is right. फिर mistake कर दिया. Yes, Nirvesh. Don't be in a hurry. Simple questions. Don't be in a hurry. जरा ध्यान से देखना है. ध्यान से देखना है. Omega is equal to 100 pi. From that you got the hint. All of you understood, dear students? All of you understood? Okay. Shall we go for the last question of the CRO so that I can start the error analysis? So that I can start the error analysis. All of you understood? Can you show me the thumbs and tar symbols? Dear students, I need energy, bhaiya. If you are not understanding, at least if you are understanding my basic language, you can respond. I am expecting a response. Any doubts here? Bhanu Prakash, Bhanu, other students, all of you are following na? Chalo. Chalo. Let us go for the next question. Let us go for the next question. Yeah. Yeah, try to do this question. Very good question. Chalo. The two signals S1 and S2. The two signals, this is S1 and S2, as shown in figure, are applied to Y and X deflection plates. So S1 is applied to Y deflection plates. S2 is applied to X deflection plates. Deflection plates of an oscilloscope. The waveform displayed on the screen is dash. The waveform displayed on the screen is dash. Yeah, try to do it now. This is the S1. Okay, na? This is S1, dear student. This is S1. This is S2. Clearly given na S2. This is S2. Okay. So S1 is connected to Y plates. S2 is connected to X plates. Then what is the waveform displayed on the screen? Generally, who is our unknown signal? Unknown signal will be S1. Am I right? So unknown signal will be which is connected to Y plates. Which is connected to Y plates? This is the connected to Y plates, a triangular waveform and a square waveform. So what type of signal we are going to get? So let us do like this. First for X1, so that is, let us take Vx plates. Voltage applied to the X plates. Voltage applied to the X plates is S1 or S2? Please tell me first. Voltage signal applied to the X plates. Voltage signal applied to the horizontal plates is S1 or S2? Fast. Voltage applied to the horizontal deflection plates is S1 or S2? Fast. Answer my question. Voltage applied to the horizontal deflection plates is S1 or S2? I am expecting response. Voltage applied to the horizontal deflection plates is S1 or S2? Very good. S2. So S2 has to be first. So S2 has to be first, dear student. So first to draw this particular waveform. Okay. Let us try whether it is possible, whether it will cut or not. Let us try. I think it won't cut. I think so. Let us try. This particular waveform is going to cut. Yeah, again the same waveform is coming. Okay, I will do one thing. I will draw it. Okay, better I will draw it. So S2 is the first wave. S2 is the waveform connected to the X horizontal plates. फटाफट draw करेंगे, जल्दी से जल्दी draw करेंगे. So what is the waveform? So this is our waveform. Be attentive in the class. So this is the connected to X plates. Okay, so this is our signal over a period of time. Okay, over a period of time. Okay, so let me try it with patience. So this is 0, this is 1, this is -1, okay na? And this is t, okay, this is 2t. Okay, I will do one thing. So this is t by 2, this is t by 4, this is t by 2, this is 3t by 4, and that is t. Okay na? Chalo. That is our, yeah, that is our Vx. Next, what is Vy? What is Vy? Voltage applied to the vertical plates. Voltage applied to the vertical plates is S1 na? So this is S2 and this is S1. To confuse you, he has given first diagram that and second diagram this. Okay. So voltage applied to the Vy plates is S1. So that waveform also I am drawing. Have patience. Then only you will get the answer. ज़्यादा पेशेंस चाहिए लाइफ में. जल्दी से जल्दी हरी बरी कुछ नहीं करना. If you do in hurry bari, definitely you are going to do mistakes. Yeah, if you see this one, so if you observe this, this is going to be covered in T. This is a triangular waveform. Okay, so how to draw the triangular waveform? So like this, in T by 2 it is touching. Okay na? Clear? Followed or not, dear students? Next to 3 by 2 again touching, and this. Fine, perfect, perfect. So now if you draw a line, so at T by 4, what is the amplitude? If you check this, this is a 1. So this is 1, this is 0, this is -1. Dear students, listen carefully. At T by 4, it is how much? 1. At T by 2, it is 0. At 3T by 4, it is -1. And at T, it is 0. Okay. So now how to make the resultant? Dear students, थोड़ा ध्यान से सुनिए. How to make the resultant? How to make the resultant? So let us make some pictorial analysis here. Pictorial analysis. चलो फटाफट करेंगे. चलो. At t is equal to 0. Okay, dear students, following all of you. At t is equal to 0. Tell me, what is x, what is y? What is x, what is y? That means voltage applied to the x plates is 0. This is also 0. So 0, 0 na? Voltage applied to the x plates. This is voltage applied to the x plates na? Dear students, compare karo. At t is equal to 0, voltage applied to the x plates is 1 na? What is x comma y? Fast tell me. X comma y is equal to how much? 1, 1, and this will be 0. Followed or not? Please show me the thumbs. At time is equal to 0, this is 1 and this is 0. Voltage applied to the x plates is 1, voltage applied to the y plates is 0. Followed or not? Followed or not? So this is for t is equal to 0. Next, at t is equal to t by 4. At t is equal to t by 4, what is x and what is y? Fast, tell me fast. At t is equal to t by 4, x is how much? 1. X is how much? 1. And y is how much? Tell me yaar. Y is how much? Y is also 1. Perfect. 1, 1. Correct? 1, 1. Correct? Followed? So second one. Next. At t is equal to t by 2. All of you are following beta. So if you want, you can draw the line also, no problem. This is at t is equal to t by 4. Okay na? So this is at t is equal to t by 2. This is at t is equal to 3t by 4. This is at t is equal to t. Okay na dear students? Now tell me. At t is equal to t by 2. If I am doing any mistake, you can guide me, no problem. If anywhere any mistake is done, please correct me. At t is equal to t by 2. X is how much? X is how much? At t is equal to t by 2. At t is equal to t by 2 is how much? Minus 1 na? Minus 1. At t is equal to t by 2, this is 0. 0. Followed or not, dear students? Next. Just I am rising. At t is equal to 3t by 4. Fast. At t is equal to 3t by 4, what is x comma y? Tell me. At t is equal to 3t by 4. At t is equal to 3t by 4, x is equal to minus 1, y is equal to minus 1 or not? Yes, minus 1. Followed, last step. भैया I am waiting for response. मुझे response चाहिए. At t is equal to last step. बोलिए. At t is equal to t. At t is equal to t, what are the x components and y components? What are the x components? At t is equal to t, x is equal to minus 1 na? X is equal to minus 1 or not? Yes, it is minus 1. And at t is equal to t, this is how much? 0 na? 0. Okay, all of you fine? All of you followed? Chalo, now let us draw the pulse. What pulse we are going to get? Okay, so if you take, this is x axis, this is y axis. Now at t is equal to 0, what is x? 1. All of you are following? X is equal to 1, y is equal to 0. So x is equal to 1, y is equal to 0. X is equal to 1, x is equal to 1, x is equal to 1, fast, x is equal to 1, y is equal to 0. Chalo. Next, at t is equal to t by 4, x comma y both are 1, 1. At x is equal to t by 4, x comma y both are 1, 1. So what you are going to get jaldi? So which waveform is going to match? एक बार check कीजिए. Yeah, I think it is matching now. Which is matching fast in this? At t is equal to 0, x is 1, y is equal to 0. Correct. This is matching. Next, at t is equal to t by 4, both are 1, 1. Perfect. At t is equal to t by 2, minus 1, 0. Perfectly matching na. Yeah. Now tell me, at t is equal to t by 4, at t is equal to t by 4, what you are going to get? 1 1 comma, you are getting 1 comma 1 na. I think we have done a mistake, small mistake here. I'm sorry. Correct. At t is equal to 0, perfect na? So this one, this is 1 comma 0. Don't confuse. Yeah. Listen. At t is equal to 0, x is 1, y is 0. At t is equal to t by 4, these are 1 1. See the waveform, it is going like this. This is 1, this is 1. Next, at t is equal to t by 2, x is minus 1. At t is equal to t by 2, x is minus 1. X is minus 1. It is going like this. At t is equal to 3t by 4, minus 1 comma 1. So minus 1 comma 1. So minus 1 comma minus 1. Minus 1 comma minus 1 here. So it is coming like this. It is coming like this. Okay na? It is coming like this. Next, at t is equal to t minus 1, x is equal to minus 1, y is equal to 0. Okay? All of you followed? Yes or not? Option A is coming. Option A coming na? At t is equal to capital T, what is this? X is equal to minus 1, y is equal to 0. Okay? So it is matching with this particular one na? Perfect na? थोड़ा सा ध्यान से देखना है, आपको आंसर आएगा. Okay, this is at t is equal to 0. Okay, so this is at t is equal to half t of 3t by 4 like this. Clear all of you? थोड़ा सा ध्यान से देखना है. रुचिता clear? Other students clear? So if you draw the graph, you are going to थोड़ा सा ध्यान से लेना है, otherwise you won't understand. At t is equal to 0, 1 comma 0. At t is equal to t by 4, 1 1. At t is equal to t by 2, minus 1 comma 0. Minus 1 comma 0. Next comes minus 1 minus 1. And the last comes minus 1 0. So the arrows also we can show. The arrows also we can show like this. It will go like this. Understood? So this is the pulse. Like this it will go. Like this it will go. Okay na? 1 1 के बाद minus 1 0 आएगा. So like this it will go. Minus 1 0 के बाद minus 1 को जाएगा. Next minus 1 से again minus 1 to 0 आएगा. So this is the pulse we are going to get with respect to axis. All of you understood, dear students? Now it is fine. Now it is fine. Chalo. I think now all of you got it. Clarity hai? Picture clear? Chalo. Thoda sa fluctuation in the signal. Okay. Just the wire connection has been. Now it is visible. Everyone, now it is okay. Fine sir, fine. Thoda sa there is just a small fluctuation in the wire connection. All of you understood na this question? Beautiful question na? Chalo. Now आज का टॉपिक स्टार्ट करेंगे. आज का टॉपिक है एरर एनालिसिस. सो उसके लिए मैंने थोड़ा सा इंफॉर्मेशन कनेक्ट किया आपके लिए. सो इन दैट इंफॉर्मेशन विल डिस्कस अबाउट द एरर एनालिसिस. चलो आज थोड़ा एक्सटेंशन भी करेंगे क्लास का. सो इफ डियर स्टूडेंट्स, let us start with error analysis. Let us start with error analysis. One of the important topic, error analysis. Okay. Chalo. So dear students, errors. One of the important topic, error analysis. Error analysis has to be, every year we are getting one question on the error analysis. Okay. Yeah, now it will be fine. I think there is a small signal. Now it is clear na? Chalo. So there are certain types of errors. The types of errors. What is error? Generally, whenever you are doing some measurement in a lab, whenever you are doing a measurement in a lab, definitely what actually you are measuring sometimes may not be correct. Okay. So what you are getting may not be correct to the true value. So there are types of errors. So these are the types of error, dear students. Gross error, visible na? So just I want to expand for you. So this is what we call gross error. Gross errors, systematic errors, random errors. Gross errors, systematic errors, random errors. Telegram link will be clear. Not clear. Now clear. Yeah. Gross errors, systematic errors, random errors. Any idea about gross errors, systematic errors, random errors? So that's what I have given you the explanation here. What is gross error? If you see the gross error, what is gross error generally? So gross errors are due to human mistakes. Whenever you are taking the reading, suppose the human being is not properly standing or not properly connecting the instruments, those type of errors are called human mistakes. Okay. So this is actually not with the instrument. This is actually not with the instrument. This is not due to instrument beta. This is just due to experimenter. The person who is doing the experiment is not standing properly. Just the experiment is going on like this. He is seeing like this or seeing like this. Or he has not connected the equipment properly. So the errors which are happening due to human mistakes, those are called gross errors. Gross errors. Gross errors mainly covers the human mistakes in reading instruments and recording and calculating measurements results. Okay. Some people will be having oversight. Some people will be having sight problem. Due to oversight, they may read of the temperature 31.5 degrees Celsius temperature को because of some sight problem, oversight की problem थी सर क्या होता है? They will read it as 21.5 degrees Celsius. So remember dear students, gross means by human errors. Okay ना? So keep this in mind. Gross बोलो तो human errors है. Clear है आपको? चलो जल्दी सर जल्दी से जल्दी बोलिए. हम ज़्यादा questions भी करना है आज. Errors के बारे में some more questions we have to do it. So all of you understood? Gross error is due to human error. Clear? Sight problem होता है. He may not see standing properly. He will be saying some cross में देखता है, ऐसा देखता है. So because of all that we are going to get an improper reading. So that is called gross error. Is it clear dear students? Gross errors are due to human mistakes. Chalo. Next comes systematic errors. Next, before going to gross errors, one more thing. I have given some clarity information. Gross errors may be of any amount and then their mathematical analysis is impossible. Dear students, ये questions बहुत important है. See, can you eliminate the gross error? Can you eliminate the gross error, Mukherjee, Ruchita? Why? Because the mistake is not due to the instrument. Dear student, the mistake is not due to the instrument. Dear student, Ruchita, just before the video was disconnected. Just before the video was disconnected. It is due to human error. I have not connected that cable properly. Something has disturbed. Otherwise, my signal is coming to the camera and the camera is capturing my video and the video is connected to system. So somewhere some connection error. That connection error is not due to instrument. Who has connected that? I have connected na. So myself I have connected. That's why. So this error elimination kaisa karna hai? I have to go there and I have to rectify it. Agar my mistake kiya, if I don't know that I have done mistake, it cannot be rectified. Do you understand? It is not due to instrument. It is due to human mistakes. The human being has not connected the instrument properly. That's what I am telling. Gross errors analysis is impossible. Okay. So what we have to take? Just we have to take great care. Care must be taken. While you are recording and while you are reading, proper care must be taken. Suppose 2 to 3 times you have to verify. Before taking the class itself, I have to verify 2 to 3 times whether this video is working or not, audio is working or not. Suppose I am taking the class. Mukherjee, I am taking the class. Suppose this connection टूट गया. The mic का जो कुछ connection है, this mic का connection टूट गया. Or I forgot to put the batteries here. I forgot to put the batteries in this mic. Then क्या होता? I go on talking, आपको audio नहीं आता. I will be searching here and there. What happened? Everything is working, but what I have done? I have forgot to keep the batteries here. Keeping the batteries I have forgot. That is a human mistake, right? That cannot be rectified. I have to recheck. And I have to. अच्छा, मेरा mistake है. Mic का mistake नहीं है. Camera का mistake भी नहीं है. I forgot to keep the batteries. समझ में आपको? So human mistakes, see, there is a good proverb, right? It is easy to judge others. It is not so easy to accept our mistakes. Am I right or not? It is very easy to it is very easy to comment on the others' mistakes, but it is not so easy to accept our mistakes. Because ये हमारा error है ना, हमारा error को हम नहीं accept करते. मैं जल्दी बोलता, सर signal का problem बोलता immediately. Suppose without verifying that particular connection is happening to my camera or not, I can say in the comment box, network issue, internet problem, rain problem, thunderstorm. These are what? Throwing the error onto the environment. But actually what is the error? Actually the error is what? I have not kept a. See, why you are asking again and again? See, this is what the disturbance in the class. Okay, please don't disturb. Okay, Prince, Telegram link is there already. Just above your comment itself, there is a Telegram link. Prakash, Prince, above your comment itself, there is a Telegram link. Why you are posting bar? Okay, don't post again and again. Chalo. So gross errors are human mistakes. So how to rectify? To rectify that, the human being has to re-verify. Okay, na? Clear doston? All of you understood? Please show me the thumbs. If you show me the thumbs, I can go for the next. Is it clear or not? Chal. Next comes systematic errors. Yeah, this is now beautiful. Systematic errors. System के अंदर errors होता है ना? Systemic errors can be classified into 3 categories. IEO. Remember like that. Instrumental errors, environmental errors, observational errors. Instrumental errors, environmental errors, observational errors. Clear na? Instrumental errors, environmental errors, observational errors. These are what we call systematic errors. Instrumental errors means what? Due to instrument. Okay. So let us see in detail. I have collected some data for you. So for example, instrumental errors. Instrumental errors means what? Shortcomings of the instrument. Suppose if you are using in a PMMC we are having the spring control. Because of continuous uses, what happens after some period of time, the spring will have its lifetime, right? The spring gets damaged. See here. If the spring used in a permanent magnet instrument has become weak because of continuous usage, then the instrument always reads high. Why? Because controlling torque has been not there, only deflection torque is there. So errors may be caused. Next, due to misuse of the instrument, you don't know where to connect to plus and minus. So these all will come under Loading error, one of the important point, dear students, loading error. Do you remember loading error? Loading error. Loading error is due to what? Meter resistance, na? Meter resistance. Do you remember? In potentiometer, I told you, meter resistance must be more than the potentiometer resistance. You don't know this. You have opted a meter. This is what error? This is what error? This is what error? This is what error I can say? Connection error, right? I have not connected it properly. So that is a gross error. Chalo. So systematic errors, misuse of the instrument. While using that instruments, you have not used them properly. Very good. So this is instrumental errors. Second comes environmental errors. Sure. Environmental errors are also important. What is environmental error? On your instrument, definitely some external temperature effect will be there. On your instrument, some external magnetic field effect will be there. So these are not in your control. These are environmental errors. The errors provided due to the conditions of external measuring device, including the conditions in surrounding of the instrument. For example, it may be due to temperature or it may be due to pressure. Okay, na? So errors created due to temperature and pressure. Next, last one comes observational errors. What is observational errors? Parallax error. Parallax and incorrect conversion of units. Okay, na? So while you are measuring, you are making some average wrong scale reading. Wrong scale reading or wrong recording. Parallax error. Okay, observational error. These are not the, when you are taking the readings, dear students, try to understand, Rahul Jaiswal. Due to taking the readings, you have taken some average. In doing that average, you have done some wrong observation. See that is a point. Wrong scale reading and wrong recording. Inaccurate estimate of average. These are what systematic errors, observational errors. In systematic errors, there are three errors: instrumental errors, environmental errors, observational errors. थोड़ा सा difficulty है remember करने के लिए, लेकिन I will tell you, errors created due to environment, they will be under environmental errors. Errors created due to your calculation mistake, observation mistake, that is also observational error. Okay ना, समझ में आपको? चलो. Now, random errors, this is most important यार, random errors. ये क्या है? Random errors means what you know? आप कितना भी अच्छा perfect connection दिया, whatever may be the connections you have given, okay ना? Whatever may be the connections you have given, how perfectly you have done, whatever may be the connections perfectly you have given, some errors will be there which you cannot understand. So those errors are called random errors. What errors? Random errors. Okay. See, for example, the quantity being measured is affected by many happenings in the universe. We are aware of some of the factors influencing the measurement, but about the rest we are unaware. So beautiful statements he has given. The quantity being measured is affected by many happenings in the universe. We are aware for some of the factors influencing the measurement, but about the rest we are unaware. The errors caused by the happening disturbances about which we are unaware, they are called as gross error. ये बात समझ में ना मुश्किल है. बात समझ में आना बहुत मुश्किल है। राहुल जयसवाला बहुत अच्छा एग्जाम के लिए बहुत अच्छा प्रिपेयर हो गया। यू हैव प्रिपेयर्ड फॉर योर गेट एग्जाम एक्सेलेंट वे, यू हैव प्रिपेयर्ड फॉर योर गेट एग्जाम इन एक्सेलेंट वे, ओके, यू हैव प्रिपेयर्ड फॉर योर गेट एग्जाम इन एक्सेलेंट वे। या हु इज दिस? सॉरी सर अगर आपको बुरा लगता हो, बेसिकली मुझे लगा कि मेजरमेंट्स के लिए अलग लिंक होगी, मैं यहाँ नहीं पहुँचा अभी लेकिन करने के लिए आया था। Okay Prince, you can post that later, okay? इन लोगों को क्या बोलते हैं? संस्कार, वो संस्कारहीन लोग बोलते हैं उसको। These people are the bullshit people, okay? The people whoever are writing such foolish comments over there, I should not talk about them. I should not talk about them. So your parents and your culture and your whatever that samskar that you learn, that is shown in your comments, okay? Chalo. Okay, so whatever you are unaware of the errors, those errors are called random errors. Random errors. See, for example, you have prepared for your GATE exam in excellent way. So now you are going to the GATE examination center. You are going to the GATE examination center. Everything is perfect, but suddenly what happened? Some accident has happened. Suddenly some accident has happened. You got into hospital. You got into hospital, and the examination duration was over. The examination duration was over. You are very depressed. You are very depressed. You are going accident kaisa ho gaya? It is not due to your mistake. You are just standing beneath that flyover, and suddenly some flyover se upar se some vehicle has dropped on you. Some accident has happened on the flyover, and that particular vehicle, so two cars are crashed. One car has fell down in front of your bike, that hit your front of the body, and you have fell down. It is not your mistake, and you are not even aware of this. इतना ध्यान से जा रहे हैं आप, हेलमेट पहन के जा रहे हैं, 40 स्पीड में जा रहे हैं, अच्छा प्रिपरेशन में जा रहे हैं, अच्छा विश पर जा रहे हैं, लेकिन भगवान की कृपा कैसा है, उस दिन आपका बिना, विदाउट योर अवेयरनेस सम एक्सीडेंट हैज हैपेंड. हैव यू थॉट अबाउट दिस इज गोइंग टू हैपन टुडे? नो, यू आर नॉट अवेयर ऑफ दिस. सच टाइप ऑफ एरर्स आर कॉल्ड एरर्स, रैंडम एरर्स. और रैंडमली होता है, रैंडम. समझ में आपको? इज इट क्लियर राहुल? रैंडम एरर्स का मतलब वो है which you are not aware, which you are unaware. Okay, sometimes कितना भी perfect हो, instrument का अंदर जो कुछ properties होता है, that will give you wrong reading. So such type of errors are called random errors. Okay, chalo. Now let us go for, fast we'll go for some problems now. We'll go for some problems. Yeah, try to answer this question. Question is visible to you? Fast. Question is visible to you beta? Today I will take somewhat 15 to 20 minutes extra. Okay, other students please respond. Other students please respond fatafat. Other students please respond fatafat. Is a question is visible to you? Is a question is visible to you? Yeah. I told you Nirvesh, random error ka example is which is unaware of you, which you are not aware. See, उसमें दिया है residue error दिया है इसमें. Why? Because residue errors may be due to the due to what? The asymmetric nature. Asymmetric nature. Yeah. Parallax error. Parallax error बोल रहे आप? चलो. Very good. What is the correct answer? Temperature of a bath was found out to be 76.8 degrees Celsius. 76.8 degrees Celsius. Experimenter. It is experimenter. एक्सपेरिमेंटर बोलो तो ह्यूमन एक्सपेरिमेंटर बोलो तो कौन है? ह्यूमन बीइंग. एक्सपेरिमेंटर mistakenly reads it's as 78.6 degrees Celsius. So it is a human mistake. First of all, it is a human mistake, so it will come under gross error. That's it. It is not parallax error. Parallax error means what? When the pointer is on that particular structure, suppose you are not able to identify that is called parallax error. This is human mistake. Option A, gross error, human mistake. समझ में आपको? Is it clear, Rahul? All of you understood? It is human reading mistake. While you are reading, you are not seen properly. That is a human mistake. Chalo. Sorry. See, I think some people may be confusing here. Yeah. Yeah. Answer this question. Fatafat. A 0 to 150 volts meter. So this is the voltmeter. 0 to 150 volts. Question is visible, dear students? Question is visible? 0 to 150 volts voltmeter has a limiting error of 1% of full scale reading. 1% of full scale reading. 1% of full scale reading. That will be how much? Full scale reading is how much? 150. The voltage measured by this instrument is 75 volts. The voltage measured by this instrument is 75 volts. Calculate the limiting error in percentage. Yeah. Chalo, answer please. I am expecting the answer from you. I am expecting the answer from you. I think the question somewhat, I will enlarge the question. Now it is visible. A 0 to 150 volts voltmeter, a 0 to 150 volts voltmeter has a limiting error of 1% of full scale reading. So this is our total reading, 0 to 150. So 150 volts is the full scale value. So 1% of full scale value, 1% of 150 volts. That means how much? 1 by 100 of 150. 1 by 100 of 150 means 15 by 10. That is 1.5. So 1.5 volts is the error over a full scale reading. That means what? Whenever it has to read 150 volts, how much it will read? It will read 1.5 lesser. Okay, na? It will read 1.5 lesser. All of you clear? 1.5 lesser. This is the error over 150 volts. But the voltage measured by the instrument is 75 volts. Voltage measured by the instrument is how much? 75 volts. So for 75 volts, what is the error? That is what we call limiting error. Dear student, if error is expressed over the full scale, that is what we call GAE error. What we call this as? Percentage of GAE. What is percentage of GAE? Guaranteed accuracy error. Guaranteed accuracy error. Guaranteed accuracy error. Okay na? Guaranteed accuracy error bolte hain usko. If the error is expressed over the full scale, then that is called guaranteed accuracy error. If the error is expressed within that full range, not the full range, at a particular value, not lower and not higher, within the middle somewhere it is asked, that means you are limiting the error. You are limiting the error, then that is called limiting error. All of you clear, dear students? Guaranteed accuracy error. Guaranteed accuracy error is always expressed. Guaranteed accuracy error is always expressed over the full scale. Guaranteed accuracy error is always expressed over the full scale. Other than that, somewhere in the middle, if you are expressing, suppose you are measuring the value of 70 volts or 30 volts, that means your error is going to be limited, na? So what is the limiting error now? So is asking for 75 volts. So limiting error means measurement value minus true value, that is error. Error expressed over the limited value. Over the limited value is how much? 75 into 100. So what is the answer? What is the answer? 15 by 10. How much is the percentage? 1.5 by 75 into 100. How much you are going to get? 2%. Okay? 2%. Clear, all of you? 2%. Suppose if you are measuring for 50 volts. Suppose you are measuring for 50 volts. Kitna hoga wo? Suppose you are measuring for 50 volts. 1.5 by 50 volts. 1.5 by 50 into 100. Error kitna hoga? 3% ho raha hai na? Suppose you are measuring for 100 volts. Error kitna ho raha hai? 1.5% हो रहा है. ओके, आंसर तो 2% है, आंसर तो 2% है. व्हाट आई वांट टू एक्सप्लेन हियर इज, if are expressing the limiting error to the 75, 2% is the error. If are expressing the error towards the zero, that means I am expressing for 50 volts. For 50 volts, what is the error? What is the error? For 75 volts, the error is 2%. For 50 volts, the error is 3%. And when you are going for 100 volts, for 100 volts, the error is 1%. The error is how much? 1.5%. That means what do you understand? What do you understand? As you are moving, limiting error is going to be decreased if you are going towards the full scale value. Limiting error is going to be increased, you are going to the lower extreme value. All of you understood? Please make a note of this point. Please make a note of this particular point. Got it? The limiting error is variable. Okay, percentage of limiting error is variable. It goes on varying. As you are moving towards the full scale value, the error is going to be reduced. As you are going towards the minimum value, the error is going to be increased. If the error is expressed over the full scale, then that is called guaranteed accuracy. Oh, error to guarantee hai. So see, I am purchasing a voltmeter. The shopkeeper is giving me a voltmeter, and he will say one thing, Bhaiya, this voltmeter will have 1% pakka error. 1% error when you measure full scale. That means what? When you are measuring 150 volts, इसका reading कितना है? Maximum reading 150. If you are measuring 150 volts पर आपको 1% error पक्का आएगा, वो तो guarantee error है. So always he will express the error over the full scale. लेकिन आप घर को चलने के बाद क्या किया आपने घर में? You are not measuring 150 volts, you are measuring 75 volts. 150 volts को 1% error बोलो तो 75 volts को कितना error आएगा आपको? 2% आएगा. Error बढ़ गया. अगर आपने, if you are measuring the lower values, error is going to be increased. If you are going to the higher values measurement, error is going to be decreased. Please make a note of this point. Okay, chalo. Next question. Yeah, try to answer this question. I think the question is visible to you clearly. Yeah, calculate the current I4. If you see the picture clearly, I1 is the current entering, I2 is also the current entering, I3 is also the current entering, and I4 is the current leaving. I4 is the current leaving. Okay na? Chalo. I4 is the current leaving. According to Kirchhoff current law, currents entering must be equal to current leading. So I4 must be equal to I1 plus I2 plus I3. I1 plus I2 plus I3. But he has given, in measuring the I1, there is a error of how much? 5%. In measuring the I2, there is an error of how much? 7.5%. In measuring the I3, there is an error of how much? 1.25%. So question asked is, calculate the current I4. Okay, so what is the answer? Yes, correct. Yes, you are correct, Rahul Jaiswal. You are not going to get 150 volts. 150 volts per 1.5% कम आएगा. అంటే 1.5 volts. Yes. Chalo. How to do this? I4 is equal to I1 plus I2 plus I3. So dear students, remember, if you are getting combination of errors due to combination of sum or subtraction of quantities. कैसा करना? For example, x is due to summation of u plus v. Okay na? X is due to summation of u plus v, and u is having an error and v is also having an error. Okay na? So then what is the error in this dx? So if you check this particular dx, so what is the dx you are going to get? There will be an error in du. Okay na? There will be an error in dv. Am I right or not? Error in x will be due to that. Okay. So this is the percentage error in this, and this is a percentage error in this. Suppose if I am multiplying and dividing both sides with x, u by u, du by x, and here v by v, dv by x. So what is going to happen here? This will become u by x du by u plus v by x dv by v. So this is dx by x. Okay na, dear students? That means if he is given the summation of the currents, so what he has given the summation of the currents? In the question if you observe, these are what? Percentage errors. These are what? Percentage errors. Am I right? So these all are percentage errors. Suppose if you take the percentage error, you can get absolute error. So what is absolute error? I can write here. Absolute error. What is absolute error? I can write 5% of 2 amperes. I1 में percentage कितना है? 5% of I1 में error कितना है? 5% of 2 amperes. 5% of 2 ampere means how much here? 5 by 100 into 2. That will be how much? 10 by 100. 10 by 100 means 0.01 amperes. So 0.01 amperes is called absolute error. What we call them as? Absolute error. Dear students, is it clear? So that is called as absolute error. Next comes I2. I2 is how much? 7.5% of 1 ampere. So that will be 7.5 by 100 into 1. So that will be how much? 75 by 1000. 75 by 1000 means 0.075 amperes. 0.075 amperes. So this is the absolute error in I2. Next comes I3. I3 का error कितना है? 5 amperes plus 1.25%. 1.25% of 5 amperes. That means 1.25 by 100 into 5. That will be how much here? 520. कितना आ रहा है? 625. 625 by 0.0625. 0.0625. Am I right? 0.0625. So these all are absolute errors. Okay, dear students, these all are absolute errors. So all these absolute errors must be added or not? Okay, na? For add or subtraction of quantities, their absolute errors must be added. Their absolute errors can be added. Am I right or not? Their absolute errors can be added. Why? Because it results. So now what is the I? I4. I want I4. I4 will be how much? I1 plus I2 plus I3. So what is the I1? 2 amperes, and this is 1 ampere. 3 plus 5. 8 amperes plus or minus. If you add all these things, 0.01 plus 0.75, 0.085. So add all these things, 0.075 plus 0.01. So if you add, how much you are going to get? 5, 2, 5, 7, 1 plus 7, 8 plus 6, 14. So 0.1475. So why? Because all the 0.1475. Okay, na? Any mistake we have done? Everything? 0.1475. So I am going to get 0.1475. So the correct answer is option B. Am I right? Option B is the correct answer. Yes or not? 0.2375. एक बार चेक कीजिए किधर मिस्टेक की हमने. Anywhere mistake? 5% of 2 amperes. 5 by 100 into 2, 10 by 100. Acha, this will be wrong, right? The first one is wrong. See, we have done a mistake. We have done a calculation mistake. So this is 0.1 ampere. Human mistake. 10 by 100, 0.1. Okay. So now if you write here 0.1. So 5, 2, 5, 0.2375. Correct. 0.2375. Perfect. 0.2375 amperes. Okay, dear students. When you are doing the errors by using the sum of quantities or subtraction of the quantities, their absolute errors can be added. Chal, next question जाएंगे. Yeah, try to do this question. Try to do this. A resistance is measured by the voltmeter ammeter method employing DC excitation and a voltmeter of very high resistance connected directly. So is measuring a resistance R by using VI method. If the voltmeter and ammeter readings are subject to maximum possible errors of 2.4% and 1% respectively. So voltmeter में error कितना है? 2.4%. ammeter में error कितना है? 1%. Then possible percentage error in the value of resistance. What is the answer, dear students? Yes, correct. What is the correct answer? See, this is what we call R is equal to V by I. In V there is an error of how much? 2.4%. There is an error of 2.4%. Excuse me. And here there is an error of 1%. Then what is the resultant error? The resultant error will be 3.4% na. Why? Because in calculation of errors due to product or division of quantities, their percentage errors can be added na? Percentage errors can be added. Their percentage errors can be added. See, you can write like this. Suppose if you take x is equal to uv, x is equal to uv. Okay. So if you take this particular dou x, okay, if you take particular dou x with respect to x, dou x with respect to x. Okay na? So this will be first you will be doing with u, so that will be dou u by x, okay na, keeping that as constant. Next it will be v dou v by x, so if you multiply both sides with u and u, you are going to get dou u by dou u, then dou v by dou v. So there what happens, the percentage errors are going to be added. Okay, always remember, in calculation of errors due to sum of the quantities or subtraction of the quantities, their absolute errors can be added. In calculation of errors due to product or due to division, their multiplication can be added. Who is this gentleman? Yeah. Chalo, next let us go for the next question. Yeah, how to do this question? Suppose that the resistors R1 and R2 are connected in parallel. R1 and R2 are connected in parallel to give an equivalent resistor R. If resistors R1 and R2 have the tolerance of 1% each, the equivalent resistors R for the rest of the resistors R1 300 and R2 200 will be dash. So this is one of the beautiful question. He is asking for the parallel combination. He is asking for the parallel combination. So how to do this question? Yeah. Suppose that the resistors R1 R2 are in parallel. So कैसा करना? So R equivalent क्या होगा for parallel combination? R equivalent will be R1 R2 by R1 plus R2 होगा. R1 R2 by R1 plus R2 होगा. Okay. So if you see here, what is the way of doing this question? Suppose that the resistors R1 and R2 are connected in parallel to give an equivalent resistance R. If resistors R1 and R2 have tolerance of 1% each, then the equivalent resistor for resistors 300, 200. What is the true value? R true value कितना होगा? Suppose if there is no error, what is the true value? R1 will be 300 ohms and R2 will be 200 ohms and R1 plus R2 will be 300 plus 200 ohms. Am I right? So this will be how much? I think 120 ohms. It will be 120 ohms. Am I right? It will be 120 ohms. This is a true value. But now what is telling? He is telling 1% of error in this. Okay na? So what is the error? If you take R1 is what? 300 ohms plus or minus 1%. That means what? 1% means 1 by 100 of 300 ohms. 1 by 100 of 300 ohms means what? 3 ohms extra. That means R1 is 303 ohms. R1 is 303 ohms. Next R2 is how much? R2 is 200 ohms plus or minus 1%. Okay na? So 200 ohms lo 1% means 2 ohms. 2 ohms. Then what will be the R2? R2 will be 200 plus 2. That will become 202 ohms. Okay na dear students? So if you consider the errors, 1% of 300, 3 will be added 303. 1% of 200, 2 will be added 202. So now what is the measurement value? Measurement value will be these errors R1 R2 by R1 plus R2, including the errors. If you check how much you are going to get, check, this is 303 into 202 by 303 plus 202. Can anybody tell me exactly how much it is? So this is 505. Can anybody calculate and tell me what is the value of this? Anybody? Fast. 303 into 202. How much here? The value of 303 into 202. Please calculate it with me. 303 and 121.2. Thank you, thank you. What about other students? Are they sleeping or they are not doing? Okay, resultant बोल दिया ना आप. So remaining students, what happened? They are sleeping, huh? Okay, you sleep. We will teach lessons even at 11 o'clock also. 121.2 ohms. So what is the error now? So you have to get 120 and this is the error. Okay. So measured value is 121.2. Measured value is 121.2 ohms. True value is 120 ohms. So what is the error? Percentage error means measurement value minus true value by true value into 100. So that will be how much? 121.2 minus 120 by 120 into 100. So how much you are going to get? If you check 121.2 minus 120, that will be 1.2. 1.2 by 120 into 100. 12 by 1200 into 100. 100 cut. You are going to get 1% error. Okay, na? So what is the answer? 1%. Yes. See, this problem is somewhat tricky. Some people will be doing like this. By taking sir R1 R2 means their percentage errors can be added. R1 plus R2 means their absolute errors can be added. But remember, these two are not same quantities. These two are R1 R2 is different. R1 plus R2 as an entity is different. R1 plus R2 is different from R1 R2. It is not a single term. Okay. So you cannot take here the percentage errors cannot be added here. Don't think sir R1 R2. For the product percentage errors can be added. For the division also percentage error can be added. But here R1 plus R2 jo kuch hai, there you are going to add its absolute error. So you cannot compare this with the previous problem of U by V method. You may be having a doubt, sir. Previously we have taken like this now. Previously we have taken like this. So previously we have taken like this. Previous problem jo kuch hai, that we have taken like this. We have directly, so here in this problem, directly we have taken V by 3.4%. Yes or not? You may be thinking like this, sir, R is equal to V by I. So V by I means 2.4% and I means 1.0%. So if you add 3.4% is the answer for previous problem. In a similar way, you will be expecting R equivalent is equal to R1 R2 by R1 plus R2, sir. So for R1 plus R2, I will calculate the percentage error, and R1 R2 I will calculate the percentage error. These two I will add. No, it is wrong. That is a wrong methodology. You cannot follow that method. Because this is not an individual one, it is a different one. It is a percentage error in either in not R1, not R2. These are percentage error in R1, these are percentage error in R2, so you can add. But what you are getting here is not the percentage error. What you are getting is the absolute error of the R1 plus R2. So this is not correct. Do you understand this method? That's what, gentleman, that only I am telling. You cannot do that method. Gentleman. That is wrong. Why? Because here percentage error of R1, percentage error of R2, their product, they can be added. But what you are taking absolute error of R1, absolute error of R2, that summation is not the absolute error of individuals. That is absolute error of R1 plus R2. That is absolute error of R1 plus R2. Remember, dear students, absolute error of R1 plus R2. That is not the percentage error. Do you understand? That's why you cannot do that. Is it clear? So you can do for this type of problems, no problem. This is valid. Or you can do for these problems, valid. But you cannot do the same method for this B plus C. Why? Because this is different and this is different. B plus C का percentage error है वो. ये B plus C का absolute error है. B plus C का absolute error is not related to individual absolute errors. Got it, gentlemen? You understand? That's the important of this problem. Many students will make the mistake of taking this. All of you understood? All of you understood. Why? Because this is not the percentage error of individuals. दिस अ परसेंटेज एरर ऑफ R1 प्लस R2. सो आपने क्या किया, R1 का एब्सोल्यूट एरर निकाला, R2 का एब्सोल्यूट एरर को निकाला, बोथ को ऐड किया, R1 प्लस R2 का एब्सोल्यूट एरर आया. That is the absolute error. From that you are getting the percentage error of R1 plus R2. Got it? That is the percentage error of R1 plus R2. It is not individuals, not individuals. Clear na? That's why in these questions, especially in the parallel combination of resistor, you cannot use that method. Chalo. Try to do this question. See here. So this is the question. A variable W is related to three other variables x, y, z. Has the relation W is equal to xy by z. Now this is fine. It can be simple. That is xy by z. Sir, time taking है तो क्या करना भैया? That is the only methodology. That is a correct methodology. If you want to do another way, that is also possible. That is the uncertainty method. If in the question he has given uncertainty, then you have to go for uncertainty method. You will get wrong answer, gentlemen. If you go with that method, the answer will be wrong. See, if you go with this, R equivalent is equal to R1 R2 by R1 plus R2, this particular method. What you are thinking? R1 1% na? So R1 300 ohms, 1%. 1% means how much? 3 ohms. Absolute. R2 absolute 2 ohms. Okay. So R1 plus R2 कितना होगा? R1 plus R2 5 ohms होगा. 5 ohms होगा. So R1 plus R2 बोलो तो 500 ohms. 500 ohms में कितना percentage is 5 ohms? So if you simplify, you are going to get 1%. Okay ना? 1%. So R1 R2 का R1 कितना है percentage? 1%. Okay. R2 कितना है percentage? 1%. Okay, so their percentage errors can be added. R1 plus R2 का कितना आया? 1%. So you will get the answer as 3%. But 3% answer is not there. 3% answer is not there. Yes, gentlemen, 3% you are getting now. If you take R1 is equal to 3 ohms, R2 is equal to 2 ohms, absolute errors, the resultant absolute error is 5 ohms. So resultant absolute error, if you are expressing in the percentage of 500 ohms, 500 ohms में x by 100 is equal to 5 ohms, that is equal to x is equal to 1%. So this resultant is 1% and this resultant is 2%. Why? Because product na. Product means their percentage can be added. Product means the percentage can be added. So what is the resultant? 1% plus 1% plus 1% as per your methodology. 3%. Answer nahi hai na 3%. 3% is not there. Yeah, and one more thing I want to tell you. This R1 plus R2 में ये percentage error है. This is not dependent on one parameter. It is dependent on R1 separately, R2 separately. Whereas this is 1% is of individual R1, this 1% is of individual R2. But this is what? 1% of R1 plus R2. Got it? That's why it is wrong method. Okay na? Even though it's time taking, you have to follow this method only. Especially for parallel combination. Especially for parallel combination. If it is a series combination R1 plus R2, directly you can take their absolute errors can be added. Yeah, try to do this problem. I hope all of you understood. अगर आपको understand हो तो आप अच्छा response दे सकते हैं. Gentleman, are you my old student? Gentleman, may I know your name? Gentleman, what's your name? A variable W is related to three other variables X, Y, Z. W is equal to X, Y by Z. The variables are measured with meters accuracy, accuracy plus or minus 0.5% of reading, 1% of full scale value, and plus or minus 1.5% reading. So what is this? X is having accuracy of how much? 0.5% of reading. I am writing in short. RDG means reading. Next. Y is 1% of full scale value. Next. Z is 1.5% of reading. So this is the point you have to understand, dear students. Okay. Raju, do you know me? Are you from which? Are you from earlier any academy like ACE Academy? Any other academy se aaya aap? Yeah. So here, this is the information about. This is the information about accuracy of plus or minus 0.5% reading. This is for X. 1% of full scale. This is for Y. And 1.5% of reading. This is for Z. X, Y, Z. So first let me take X box. Sorry. Let me take X box. This is meter X. This is meter Y. This is meter Z. So what is given? The actual readings of the 3 meters are 80, 20, 50 with 100 being the full scale reading. So for all the full scale is 100. For all the full scale is 100. For all the full scale is 100. And the meter reading, if you check, 80, 20, 50. Meter reading is what here? The meter reading here is 80. The meter reading here is 20. And the meter reading here is how much? 50. All of you are able to see this, dear students? Okay. 80, 20, 50. The meter reading is 80, full scale 100. The meter reading 20, full scale 100. The meter reading 50, full scale 100. Now what is the question? They are having the maximum uncertainty in the measurement of W will be dash. So here he has given error. You can directly take the reading of percentage. Why? Because all are in percentages. It's a product, right? It's a product. We can go in the form of percentage. So what is there for X? 0.5% of reading. What is the error for X? For X error 0.5% of reading. That means how much? 0.5 by 100 into reading. Reading kitna hai? 80. So that will be how much? Please have calculators with you and tell me the answer. 5 by 100, 5 by 10, 5, 8, 40, 400 by 1000. Am I right? 5 by 10, 400 by 1000. 400 by 1000 means 0.4. So this is the 0.4 absolute. 0.4%. Okay, na? 0.5% of the reading means that is 0.4. Okay, next. What is given? 1% of full scale value. 1% of full scale value. So for y the error is 1% of full scale value. 1% of full scale value means 1 by 100 into full scale value is 100. That will be 1. See, this is for full scale value, but what is the reading? For reading 20, what is the limiting error? For reading 20, it will be how much here? For reading 20, it will be 1 by 20 into 100. 1 by 20 into 100, that will be 5%. So actually speaking, this is no need to calculate. Why? Because this is all not necessary. Why? Because 0.5% of reading already given. So this is 0.5% of reading. Got it? Now for y we got 5% of reading. Am I right? 5% of reading. Clear all of you? Chalo. Next, for z what he has given? For z what is given? 1.5% of reading. For z error is 1.5% of reading. 1.5% of reading means how much? 1.5 by 100 into full scale value 100. Sorry. It is not full scale. What is the reading of it? 50. 1.5% of 50. 1.5% of reading. So it is also not required. Directly it is given the readings. Okay na? So with respect to readings, we got or not all of that? With respect to X instrument, 0.5% of reading. With respect to Y instrument, he has given 1% of full scale value. 1% of full scale value means 1. That means what is the percentage of limiting error with respect to this 25%? For Z, it is 1.5%. So overall, for X we got something, for Y we got something, for Z we got something. Okay. So what is the X value? 0.5% of reading. Maza aa raha hai? 0.5% of reading. And this is 5% of reading. And the last one is kya hai? 1.5% of reading. 1.5% of reading. All of you understood, dear students? So this is 0.5% of reading. Okay. So what is the question asked? He has expressed all in terms of percentages. So what you are going to get? Simple, फटाफट कर सकते हो. W is equal to xy by z. फटाफट कर सकते ना? W is equal to x, y, z. अभी देखो, ये both are product, individual products. So इसका percentage error, इसका percentage error can be added. So 0.5% plus 5% plus divided by z. It is an individual percentage error. इसका percentage also will be added, 1.5%. So answer will be 7% of reading or not. In W, we will be having an error of 7% of reading. That is the correct answer. Option D is the correct answer. 7%. मजा आया? Gentleman, Rahul Jaiswal, other students who are there. मजा आया आप सब लोगों के लिए? Clear? Followed or not? Okay. Some more problems we'll see in tomorrow. Tomorrow also we'll take a session on error analysis. आप सब लोगों को समझ में आया? I think all of you understood the beautiful problems of error analysis. So we have solved some good amount of problems today. Some quality problems we have discussed. Some quality problems we have discussed. Yes or not? Some quality problems we have discussed. So please share like anything. Please do subscribe. Please post these particular classes in your WhatsApp groups. Please post these particular classes in your Telegram channels. Actually, when he mentions uncertainty, you have to do that. When he mentions uncertainty, you have to do that. But gentlemen, the errors also must be expressed as uncertainty. Gentlemen, for that errors also must be expressed as uncertainty. When errors also expressed as uncertainty, then you can find out the resultant uncertainty. Okay? For that errors must be expressed as uncertainty. Chalo, is it clear now? Rahul Jaiswal, is it clear? So, sir, I don't have any friend circle. You have the social media. If you have the social media, you can post there. You have the social media, you can post there. You can have the, see, if you want that uncertainty errors also will do, don't worry. Uncertainty errors also will do. Chalo. So bye bye, take care, good night. Good night to one and all. We'll meet tomorrow. Have a great day. Have a great day. Thanks to all. Love you all. Love you all. Thanks to Gate Academy. And please share these comments. Please share your, I think all of you are getting benefited, right? Rahul Jaiswal. All of you are getting benefited. Please share this benefit to maximum number of students. Please make it to reach to maximum number of students. Nirvesh, maximum number of students. Chalo, tata, bye bye. Love you all. Take care.